Hello everyone. So continuing with our design pattern series, in this video we will cover flyweight design pattern. So let's get started. So we'll start with what is flyweight pattern, why we use it and how to achieve it, then its code implementation in C++, and finally benefits and disadvantages. So let's start with what is flyweight pattern. So first of all, it's a structural design pattern and it has only one job. It optimizes memory usage by sharing common state among multiple objects. Right, so we will understand what does it mean by storing common or sharing common state among multiple objects. Right, right now it seems like there are many objects which have a common state, and we want to, instead of each object have its own state, we want to create a separate one so that everyone can share it. And using this practice, it allows us to fit lot more objects in your memory which are very similar, as we have discussed above, that they have some commonality which we want to separate out from the object itself. So that is a simple description of what is a flyweight pattern, but we will only understand why we need it. So why use flyweight pattern? So this is very important to understand. So consider a forest game. Maybe we are creating a immersive game where the user can create different type of trees in a forest, right? They can go like maybe harvest the trees, create new trees. Assume it's a hypothetical game, and each tree is an object in itself. So as you can see, there are a bunch of trees we have created here. Maybe it's a dark green pine tree, light green pine tree, maybe some oak tree. So different type of predefined trees with different colors user can create. So consider this, after playing for some time, the game crashes. Now what could be the reason? The reason turned out to be insufficient RAM. So somehow the game is taking a lot of memory over time. If the user plays, let's say, for 10-15 minutes, game crashes, not in the beginning but over time. So after maybe some inspection of the logs, we notice that the issue is insufficient RAM, right? Now why? Now the one thing to notice here is, since we know each tree is a separate object, so it's a image, right? So it will have some image object, and you can consider each image has a size of 100 KB. So on it, approximately each object is of 100 KB size, and if let's say user creates 100,000 trees over time in their entire game, the space RAM cost reaches up to 10 gigabytes, which is too much, right? Like many systems will start crashing with this much memory usage. So what can we do here? One thing which comes to the mind is, maybe instead of storing each image into each tree object, since like there are finite number of trees, if you notice there are, let's say, 20 different type of trees or 30 different type of trees. So when you have 100,000 trees but there are only 20 unique trees, so what we can do, maybe we can create those 20 unique trees somewhere else, and each tree object stores the reference of the type of the tree it has, right? So if we do that, then we can bring our RAM cost way too much down, right? So the solution is, do not store image in the tree itself and store it in some common object for reuse by multiple tree objects, right? So in that sense, if you notice, if we have 100 KB per tree, and even if we have 100 different type of trees, which is way too much, it will only have 10 megabytes of memory rather than 10 gigabytes which we are having right now. So this is a very intuitive solution everyone would come up with, but that is precisely what flyweight pattern suggests. So flyweight pattern formalizes what we will already do if we will arrive at such situation. So let's say how flyweight pattern achieves this. So initially we had a forest and we had trees. Each forest, like forest is a class, it will have trees, right? And you can plant a tree, which means you will create a new tree object, and draw trees function print all the trees on the UI. Now forest class contain tree class, and tree has coordinates where the tree will be drawn, x and y coordinate, and if you imagine, it will also had a image of the tree. But now what flyweight pattern suggests is, rather than storing the image with the tree object, just store the tree type, that what type of the tree it is. Now what is tree type? So tree type is a separate class. We can call it as a flyweight class as well, or flyweight object. So tree type has name of the tree, color of the tree, and the image object of the tree. And it also has a draw function, which after providing the coordinates where to draw, it will draw the tree. So if you notice, when in the draw trees, it will call the draw function of the tree, every tree, and the draw function of the tree will call the draw function of the tree type it has with the coordinates for this tree. So tree type only contains the different type of tree objects, and tree itself contains the specific information for each tree, which is the coordinate of this particular tree, but the rest of the information is stored in a separate object which is shared across multiple trees. And to get the tree type for a given tree, we have created a tree type factory which takes color. So when we create a tree, when the forest creates a tree, it passes the name and the color of the tree along with the coordinates, and those name and color, based on that name and color, we get the tree type. So you can assume it's a map which has a key is the color and name, and correspondingly it has a tree type. So tree type factory returns the tree type. So in this map we contains all the trees. So the tree will use this factory, its function called get tree type, and if that tree type does not exist, this factory will create that tree type and return, and if it is already exist in the map, it will reuse it. So we will see it in the code, but this is how briefly it is done, and the client only interact with either the forest and the tree. So client can create a forest or client can create a tree, and internally we have a flyweight object as a tree type. So that's it with the explanation. I think now we can move on to the code. So now let's see code implementation in C++. All right, so let's start with our forest. So we have a forest, as we have seen, it has two functions, plant trees. So when it calls a plant tree, it passes the coordinates, it passes the name of the tree, maybe oak tree, neem tree, pine tree, and the color of the tree, maybe dark green, light green, or yellow, right? Any color it could have. Now now let's look at the draw tree function. Draw tree function just iterate over all its trees and call their draw function. And this plant tree creates a new tree object and pushes it in its trees. So the main logic happens inside the tree only. So let's go to, first let's start with the tree. So this is our tree class. It takes all of these parameters. Now the tree object has three variables, coordinates, x, y, and the type of the tree, reference of the tree type. So the tree type it gets from the tree type factory. So tree type factory has a static function called get tree type. It takes name and color as the input, and it returns a tree type object to this tree, right? And if you look at the draw function of this tree, this draw function just call the draw of the tree type, as we have just seen, with the coordinates. So with the given coordinate for the given tree type, print or the draw that tree on the UI. Now let's look at the tree type. So tree type class takes only two parameters, name and color. So it creates a new object with name and color, and also it creates a new image object. This image is based on the name and color we have provided. And its draw function, it's pretty simple. It just take the coordinate, and we have in this code we have just printed the drawing tree of type this name at these coordinates with this color. So here we will have actual logic of drawing the tree out. And finally the tree type factory, it has get tree type function based on the name and color, and these are bunch of structs for creating a map. Now if you notice, the map has a key tree type. So this tree type has two parameters, name and color, And since it's a custom key, we have overridden this double equal to operator, or double equal to, yes, operator, and we are just saying that if the name is equal to the name, color is equal to the color, then they both are same. And there's also this hash. Since we are using unordered map, we have to define how to calculate the hash. So I will not go deeper into this. If you want to take a look at this code, it will be in the description below. But this is just how we can identify each tree uniquely. Now main logic is in your get tree type function. So if we look at get tree type, for the given name and color, we first create the key, then we find that key in our tree types map. If it is not present, then we create a new tree. So we print that we are creating a new tree type. We create this new tree type and we assign it, we store it in the map, and then we return it. Now if you notice, if it is already present, then we directly return it rather than creating a new tree. So if a tree if a pine tree of dark green color already exists, we will directly return that object rather than creating a new one. So like this tree object will share the, like multiple tree object will share the same tree type. So we will not be creating images again and again. So let's quickly see this. I think it was already shown here. So now if you go to the main function, in main function we are creating an empty forest, then we are planting 4 trees. If you notice, these are the coordinates 1, 2, and we are planting oak tree with light green color. So as you can see here, we are creating a new tree type oak and color 0. So this is creating a new creating a tree of new type oak and light green color. Then when you plant a tree of pine and dark green, again a new tree type is created. When you neem and light yellow, again new. But if you notice in the 4th call, pine and dark greens, it's the same tree which we have created before. So now here we are not creating that 4th tree because there are right now 3 different types of trees. And now when we start drawing the trees, we will draw all of these 4 trees at their particular location 1, 2, 3, 4, 5, 6 and 2, 3 with the oak, pine, neem and pine with their given colors. So with this, we have created 3 different trees, 3 different tree types, but we are printing 4 trees. Similarly, when this will scale up to 100,000 trees, but we will have at max 100 types of trees. So this is how it helps us store save the space. So I hope this makes sense. Let's go to the final part, which is benefits and disadvantages. Benefits are pretty evident, as you can see. Flyweight pattern supports storage of huge number of objects which otherwise won't fit in a RAM. Right? If you store all of the state for each different object, you can't store all of them in a RAM. But in this way we can. And it reduces the overall memory footprint of the application. Okay, so these are the benefits. Now let's go to disadvantages. So the disadvantages, first is there are more hops to draw the tree, which may increase the CPU cycle. If you notice, tree itself doesn't contain its entire state. So we have to go to the tree type factory to get the tree type, and then we call the draw function of that tree type to draw the tree. So as you can see, there are multiple indirections due to which your CPU cycles will increase while we are saving RAM here. So it depends on whether we want this trade-off or not. For high performing applications, right, game are very heavy. So in game we can afford this, but if there is some high performing application, you don't want to create this indirection unless necessary. And then there is complex code due to the said indirection already. So if someone is reading your code, they might get little confused that why some part of this tree is stored outside. But these disadvantages does not matter that much if you really want to create a lot of objects which have a lot of states in common. And typically the commonality is where most of the memory lies. If you notice, the image size is 100 KB, but for the rest of the parameters, rest of the variables, it is in bytes, integer or double. But the blob or the image, they are typically very high size. And that is where we are making our savings. So that's it with the flyweight pattern. I hope this help you understand. This video will help you understand like everything about the flyweight pattern. If you have any doubt, please let me know in the comments below. And if this video help you understand the flyweight pattern, please like this video. And I have already made a lot of videos on design patterns, different design patterns, and I will continue to do so until I cover all of them. So you can watch my previous videos, and you can also I'll also be posting the more videos in the future. So until then, bye everyone.